Welcome back to Friday part 2. This is on chapter 2b to 3b on graphing and transforming quadratics. As you are aware from when we did this chapter, I am not able to check your graphs, so my hope is that you are practicing graphing quadratics, but for the sake of the final, you won't be graphing any. Instead, we'll be finding the axis of symmetry, the vertex, what the solutions are, and making sense of the domain and range. And then we're also going to look at transformations. So with a quadratic, to find the axis of symmetry, the abbreviation is AS. The axis of symmetry is a line that goes vertically through the graph, so it's x equals, and we do negative b over 2a. Don't get that confused with c equals b over 2 squared. This is completing the square, completely different. Axis of symmetry is negative b over 2a. That comes into play with the discriminant actually, so we'll look into that more in Math 3 next year. I forgot to put some graphs on here, but I will add them before posting it to Schoology. So if you would like to visualize it, you can. Again, you don't have to. So to find the axis of symmetry, we want to do negative b. So we've got a is 1, b is negative 9, c is positive 8. So negative 9, which makes positive 9, over 2 times 1. That is 9 over 2. So the axis of symmetry is the line. It's x equals 9 over 2. Or you could write that as x equals 4.5. So that means if we go over to the graph, 1, 2, 3, 4.5, and here, there's a line that goes through x equals 4.5, and this is the axis of symmetry, which means that everything on one side of the quadratic will be the same as the other side. So to find the vertex falls on the axis of symmetry, and to find the vertex, we already have the x coordinate. It's the same as the axis of symmetry, but we need to find the y coordinate. So to find the y coordinate, we need to plug this into the equation. So that is y equals, we've got 9 over 2 squared, or just plug in 4.5 squared, minus 9 times 9 over 2 plus 8. So that's 81 over 4 minus 81 over 2 plus 8. This is, least common denominator we could do is 4. So 4 over 4 times 2 over 2. That's 81 over 4 minus 162 over 4. I would not recommend doing this. My calculator is on the other side of the room, so if you need practice with your fractions, then this would be good for you. Plus 32 over 4. So we've got 81 plus 32. That is 113. Minus 162 over 4. So 113 minus 162, that is 49 over 4, which doesn't look very nice. I chose a fraction so you could see what it could look like. However, you're not gonna see problems quite this difficult. So the vertex is 9 over 2, comma, 49 over 4. Or if you did it as a decimal and you just plug that into your calculator, which would be the recommended way to do this, that would come out to 12.25. Negative. 113 minus 162 was negative 49. So negative 12.25. So 1, 2, 3, 4, 5, 6. I need to scale by 2s to make it fit. And then the x-axis I scaled by 1s. So in actuality, it would really be more stretched out, but because I scaled this by 2s, it's a little bit more compacted this way than it really would be. So 12.25, that's about here. And then we want to find whether or not it's a minimum or a maximum. And you know it's a minimum or maximum just by whatever the leading coefficient is. So if the leading coefficient is positive, then that means the quadratic is gonna open up. I remember that because if you have a positive number, it's opening up because you're happy. If you have a negative number, so if a is greater than 0, if you have a negative number, so if a is less than 0, then it's opening downward because it's sad. Yeah, I'm a really good artist too. Anyway, so this is opening up, and it's a little backwards to what you'd think. When you hear opening up, you'd think maximum, but when it's opening up, that means you have a minimum. When it's opening down, that means you have a maximum. So here, if it's opening up, if it's going to be going up, that means we have a minimum. So this is a minimum, and we want to find the roots. So where the solutions lie, which is when it crosses the x-axis. So to find where it crosses the x-axis, we want to find when y is equal to 0. So if we plug in 0 for y, 0 equals x squared minus 9x plus 8, then now we can try to factor this and see if we get solutions that come out nice and neat. So we need two numbers that multiply to positive 8, add to negative 9. So that means we need negative 8 and negative 1. That makes negative 9x, positive 8. And if you set x minus 8 equal to 0, we get x equals 8 and x equals 1. So this is a solution, and 5, 6, 7, 8, this is a solution. So the graph is going to look something like this. And if you want to know the y-intercept, that's always the c value if it's in standard form, not if it's in vertex form. It's only if it's in standard form. So I could go up here and say the quadratic's going to do something like that. But again, you don't need to graph it. This is just to make sense of what it's actually looking like. And it'll also help with finding the domain and range. So the domain is what can the x values be. And for all quadratics and everything actually that we've done this year, the domain has been all real numbers. And the reason for that is you can plug any value in for x. You can plug in any number, any negative number, any positive number, any number in between. The range, though, is the type of numbers that we get out. So for the range, the y values, we're saying, what can y be? Well, we can see here, y is not anything down here. Y is only numbers that are above this point, equal to this point or higher. So we found that the vertex was at 4.5 comma negative 12.25, which means that all the y coordinates are going to be either equal to negative 12.25 or more than negative 12.25. So that's y such that y is greater than or equal to negative 12.25. Or you can write that as negative 49 over 4. Almost forgot that negative permanently. So again, not a very beautiful one to start on, but should be a little bit easier to then do the homework problems. And then number 2, go ahead and pause this video, see if you can work it out, and then resume it when you're ready to look it over or get some help on it. So the axis of symmetry, we use x equals negative b over 2a. So that would be negative 2 over 2 times a is negative 2. Negative over negative is positive. 2 over 4 is 1/2. So the axis of symmetry is x equals 1/2. And you could graph this again. I'm not going to on this one. So to find the y coordinate, we need to plug 1/2 into this function. So f of 1/2 is equal to negative 2 times, we're going to do 1/2 squared plus 2 times 1/2 plus 4. That's equal to negative 2 times 1/2 squared is 1/4 plus 1 plus 4 That's negative 1/2 plus 5, so this is 4.5, or 9 over 2. So 1/2 comma 9 over 2, or you can write that as 0.5 comma, I forgot another reason to not write in pen, 0.5 comma 4.5. This would be the vertex, and we want to know if it's a minimum or a maximum. So again, we look at that a value. Because a is negative, that means that the face is going downwards. So if the quadratic is going down, then the vertex is a maximum. And to find the roots, we can solve for when this is equal to 0. So when y is equal to 0. So 0 equals negative 2x squared plus 2x plus 4. I don't like having a negative as the leading coefficient when I try to factor. You could plug this into the quadratic formula. I'm going to try to factor it first though. So again, I don't like having a leading coefficient that's negative, so I'm going to move everything to the left side. So this is 2x squared minus 2x minus 4 equals 0. So to factor this, we need 2x and x, and then this is going to be 4 and 1, negative, positive. So this would be negative 4x, positive 2x, which would make negative 2x, and then that multiplies to negative 4. So what I did just now is called guess and check. I'm saying two numbers that multiply to 2x squared. It's going to be 2x and x. There's no other combination to get 2x squared. And then the terms here to multiply to negative 4 are either negative 4 and 1, or negative 1 and 4, or you could do negative 2 and positive 2. So again, this is called guess and check, or you can go off to the side and factor by grouping. So that's what we did in the last video, factoring by grouping, if you're more comfortable with that. Or if you want to give this a shot, you can. You can also Google guess and check and watch a couple videos on that if you'd like. So set this equal to 0. If 2x minus 4 is equal to 0, then we get 2x equals 4, so x is 2, and x equals negative 1. So these are the two solutions, the two roots. And to find the domain, so we said the vertex is at 0.5 comma 4.5, and this is a maximum. So the domain is all the x values, which is all real numbers. All real numbers. This is the symbol for all real numbers. The range is the y values such that y is, and then if this is the maximum, then that means all of the y values are going to be less than that number or equal to that number. So y such that y is less than or equal to 4.5. And this last problem, number 3, we're going over transformations, and we want to compare them to the original function x squared. So when you see a quadratic written in these two forms, this is called vertex form. And if you look at the original function x squared, the function x squared minus 4 means whenever you plug in a value, whatever you get, this graph is just going to be 4 units lower. So it's really just shifted down 4 units. Shifted down 4, or translated down 4. The next one I want to look at is b. So for b, let's put that over here. This is negative. So the function x squared is positive. If we look at y equals negative x squared, it goes down. But this is negative and then x minus 2 squared. So the question is, what does this do to the graph? So again, this is vertex form, which looks like this, x minus h squared plus k. And k, the y value, determines whether it shifts up or down, so that's how we know this shifted down. The h value, so whatever number is in here, determines whether it shifts left or right. And because it's written as x minus h, it does the opposite of what you expect. So x minus 2 means that h is actually positive 2. And rather than trying to memorize that, I like to look at an equation in vertex form and say, what is the vertex? And then go off of that. So the vertex here, what is h? H is positive 2. And the k value, well, there is none, so that means it's 0. So in graphing the vertex, you can see 2, 0. The vertex would be here, and the function is going down because of that negative sign. So it looks something like this. So this would just be shifted or translated right 2 units. It's not shifted up or down, but it is reflected. So when this sign is negative in the front, the function is reflected over the x-axis, which just means if you took this paper and you flipped it, we see x squared goes to negative x squared. It's just reflected whenever this is a negative sign. And then c, we've got negative 2 times x plus 1 squared plus 3. So this was a, b, c. So again, this is negative, which means it's going to go down. Because it's negative 2, it's going to go down steeper. And then we want to look at what the vertex will be. So again, opposite of what we see, that means the x-coordinate is actually negative 1, comma, positive 3. So to graph this, negative 1, positive 3 would be up here. This is where the vertex would be. It's going to go down, and it's going to be steeper. So it might look more like that. And really, I just like to graph this to be able to see what is actually happening to this function. So what's happening to the function, the original function x squared, I'll just do a dashed line to represent where that was. It is reflected over the x-axis because it's going down. Reflected over x-axis. That's because it's negative. It's also stretched vertically because of the 2. Because of that 2 in the front, vertically. It will make all of the values get more negative faster, just like if this was positive 2, it would increase a lot faster. And then that vertex will tell us how it's being translated or shifted. So the negative 1 tells us that the original function is shifted left 1 unit. Shifted left 1 unit. And the 3 tells us it's shifted up 3 units. And again, you can memorize h and k, what they do, or you can just remember, if this is vertex form, I can identify what the vertex is, and I can think about the vertex in comparison to the point 0, 0, and figure out what those translations would be. And then the only other component to it is looking at that a value. If it's positive, then it opens up. If it's negative, it opens down, which means that it's reflected. And if this value is larger than 1, if the absolute value is larger than 1, and that means it's going to stretch vertically. Or if it's less than 1, then it's going to compress vertically, which means it's going to open up slower. So anyway, thanks for watching. Sorry this is an even longer video, and I'm hoping that the last ones for Tuesday will be a little bit quicker. So hope you guys are doing well, and please feel free to reach out if you have any questions.